Here we have a question that's asking how many gallons of 90% antifreeze solution must be mixed with 100 gallons of 15% antifreeze to get a mixture that is 80% antifreeze. So before we start making our equation and trying to solve this thing, let's look at it and try to figure out what it's asking and how do we go about figuring it out. So the first thing we need to know is, well, what is the question asking? What is our end result? What's our variable going to be? And you can see it in this problem right there in the first few words. It says how many gallons of 90% antifreeze. So let's go ahead and let x be the number of gallons. So x is the number of gallons of 90% antifreeze. Okay. Okay. And so now let's look and see if we can figure out what it is we're actually doing here. Well, it should be pretty obvious. We're taking some 90% antifreeze, mixing it together with some 15% antifreeze, and when we put it all together we're going to get a mixture that is 80% antifreeze. So the second thing we need to do is to look at this and figure out, well, what it looks like. Well, what are we doing? We're taking a jug, and let's go ahead and just draw a jug of some 90% antifreeze, right? So there's our jug of 90% antifreeze. And then we're going to take another jug of 15% antifreeze. So let's go ahead and draw another jug of 15% antifreeze. And we're going to mix these two together, and we're going to pour them into another container. And when we're done, we want it to be 80% antifreeze. So it's important to really understand here, not just know how to set up the problem, but to understand that we're physically going to pour this stuff into our final solution, the 90%. Then we're going to pour the 15% in. Well, now we're missing some information here. We want to know how much. How much is in each one? And obviously, all these containers are not to scale, but that's not really important. But how much is in this 15% container? Well, it says right in the problem that it's 100 gallons. So we have this container being poured in. And then how much 90%? Well, we've already set up that it's going to be X gallons. So we don't know how many gallons. And then the question is, in our final solution, how much is there going to be altogether? Well, we're going to have that of course at least 100, right? From the 15%, plus we'll have an additional X gallons from the 90% solution. So in our final solution, in the 80% solution, we're going to have 100 plus X. So let's pause for a second and make sure we completely understand what's going on here. First, let's look at the percents. We take some 90% and some 15%, mix them together, and we get something that's 80%. And it should be pretty clear to you by now that that 80% that we're trying to get has to fall between 90 and 15. If we put more 90%, we would get a stronger mixture. If we put more 15%, we would get a weaker mixture. And then let's look at the gallons themselves. This is just simply we're adding X gallons from the 90% and 100 gallons. And when we put them together, we get X plus 100 or 100 plus X gallons. So we're pretty much ready to go. We can start setting up our equation if we understand that when we add these two containers together, so we'll just add them together, that will equal our final solution. So literally, you set up the equation exactly like it looks. You say 0.15, that's our 15%, times 100. That's how much antifreeze is in this jug over here, plus 0.9 times X, that's our 90% solution, is equal to 0.8 times 100 plus X. That gives us our equation to find out how much 90% solution we have. So now we just solve it like we would any other equation. 0.15 times 100 gives us 15 plus 0.9x equals 0.8 times 100 is 80 plus 0.8x. We'll subtract 15 off both sides and we get 0.9x equals 65 plus 0.8x. Subtract 0.8x off both sides, and we get 0.1x equals 65. Divide both sides by 0.1, and we end up with x equals 650. So our final answer would be that 650 gallons of 90% solution are needed. It's important to realize here that we didn't just go straight to the setting up the equation. We started by trying to understand the problem and figure out what the problem is asking.